Today we're going to talk about some properties of trapezoids and what kind of information you'll need for your class. So we're going to go over two main things. We have the perimeter and we have the area. We'll glance over the perimeter since it's nothing really new compared to what you have been doing for shapes. But the area is slightly different and may be confusing, so we're going to talk about the formula for that. So for the perimeter, I just labeled these A, B, C, and D on the sides. No specific measurements really needed, but I wanted to reiterate that the perimeter is just the sum of all the sides. So nothing too insane there, but I did want to give a little refresher on it, especially as you're learning shapes, new information. You might forget simple things about how to find perimeter. Now, the area is where it gets slightly different. I'm going to assume that up until now, you know how to find the area of a square, a rectangle, and also the area of a triangle, which is slightly different. Now, the only reason I say a triangle also is looking at the equation of an area for a trapezoid. We have A plus B all over 2. Put that in parentheses times the height. Now, I'll write this out in another way that you might see also. You might see base 1 plus base 2 all over 2 times the height. So the reason I wrote this out in both variables and the equation you'll probably see, just so you can understand where this is coming from. So base 1 plus base 2 all over 2 times height is what you will most likely see in your textbook and another video if you decide to watch one. But I wanted to write in variable form just so you can see what that actually means. So when you have a trapezoid, you're going to have two sides that are parallel to each other, and then you have two sides here that connect the parallel sides. So you're going to have one of these sides longer than the other one, otherwise you'd be dealing with a square or a rectangle. And now the parallel sides are what we call bases. So if you wanted to flip this shape on its head, then A could be the bottom base, B2, if you want, and then B would be base 1. But that doesn't necessarily matter because all we do is add up these two bases, divide that by 2, and then multiply by the height. And you'll see the height given, something probably like this. They like to draw right at the corner there just to kind of show that's the height, really emphasize it. But the height just goes all the way from the bottom base to the top base. So you could have a line in the middle of this if you wanted to. You could have it here. Doesn't necessarily matter, but you will probably see it drawn at the corner, and you'll see a little measurement by it. So in this case, I just labeled height with H, just so it kind of stays simple. But let's look back at the equation. So we have base 1 plus base 2 divided by 2, all multiplied by the height. Now the reason I said you might want to know the equation for the height of a triangle, so we'll have something like this. Say we have a base of 3 and a height of maybe 2. The area of a triangle is base times height divided by 2, which you'll see incorporated into the equation for the area of a trapezoid. And that's no coincidence because we do see we have two triangles here. So it's basically accounting for those triangles and filling them in the area too. So if you didn't have necessarily all the information you needed, you could actually just have this, that, and then you could fill in some info. You could solve for the area of a triangle here, area of a triangle there, and then the middle square or rectangle, whatever you have here. You could just simply do that to find the area of the trapezoid. But this equation is probably what you'll go to for most situations, considering you have the information that you do need. So now going into some examples regarding these, let's draw out kind of like a different trapezoid that you probably won't see, because you're probably going to see a really neat and pretty one, but you might see, let's ignore that a little bit right there. You might see one that's kind of a little lopsided, and that can definitely happen. That's no surprise. Let's say this is 3/8. Let's draw, I don't know, let's say like a height of, I don't know, 2 or something. Definitely not proportionate, not the best at drawing, but we do know that we can still use our equation that we know and still solve for this. So we have base 1 plus base 2, all divided by 2. Put that in parentheses just to kind of separate a little bit, times the height. So we have base 1, 3, plus base 2, which is 8, all over 2 times the height, which is 2. So you could just cancel these out, but we'll do the actual problem just to kind of get a little more experience with it. 3 plus 8 is 11 divided by 2 times 2. So this is 5.5 times 2, which comes out to 11 units squared. I do want to emphasize that for area we use squared units because we're working in 2 dimensions. It's not a measurement. We're using units squared. Now your teacher might want you to put that little 2 above units, or they might want you to actually write out units squared. Neither way is correct, but it is still definitely important to understand why we're using units squared. So let's look at an example of another trapezoid here. So let's say this top one is 5, 2, and then let's say we have a height of, let's go with 3, make it a little different so not everything cancels out. So we can still use our equation for this, it doesn't change. Now we're used to seeing like a shorter side on the top of the trapezoid. I wanted to do this example to emphasize the point that it doesn't matter simply. Base 1, base 2, they can both be switched around because you're just adding them and then dividing by the sum of both of them. It doesn't matter what order you go in. So like we might say 5 plus 2, but we can say 2 plus 5. All you need to know is that you're adding these 2 bases to each other. So let's do that. We got 5 plus 2. We want to divide that by 2. So base 1 plus base 2 divided by 2 times the height, which we're given here as 3. Let's solve this. 5 plus 2 is 7 divided by 2 times 3. 7 divided by 2 is 3.5, or 3.5 times 3. And that is going to be 10.5. I want to emphasize units squared since we're working 2-dimensionally here in solving for the area. So now that we've looked at the equation and done some problems, let's go back just to understand what happened here. So perimeter, just wanted to reiterate, nothing different, and perimeter should be the same concept every time. You're adding up the length of the outside sides. So if there's stuff going on the inside, don't worry about that. You're just trying to figure out, kind of think of it like a fence, how long that fence is that goes around the shape. So A, B, C, and D for these sides, A plus B plus C plus D. So if you had 1, 3, 2, 2, 1 plus 3 plus 2 plus 2. That's all you need to know for perimeter, simple as always. But when it comes to area, it is slightly different. We have 2 bases given, and then we have the height of the trapezoid. In this case, you're going to do the bases adding each other. We say base 1 plus base 2 normally. Divide that sum by 2 and multiply by the height. This equation comes from incorporating the area of triangles into finding the area of a trapezoid. And we looked at some examples down here. We flipped the trapezoid on its head to show that the importance of knowing the equation is that you're adding up the 2 bases that are parallel to each other. So you're not adding up the sides that are slanted, you're adding up the sides that are just straight. So this one we have 3 and 8, those are the bases you're going to add up. This one we had 5 and 2, those will be the bases you're adding up. Beyond that, there isn't much more you need to know about trapezoid. Sometimes you might have limited information about the dimensions and you just have to work through it. But just make sure you practice squares, rectangles, and triangles, and you'll be able to get around any trapezoid with ease. So, I hope this was definitely helpful for you guys. If you have any questions, leave them in the comments for me. Share this with your friends, your teacher, and there's definitely more to come. So, enjoy your day. Thank you. Goodbye.